We're going to calculate delta H for the following reaction, giving the following individual reactions. Alright, so we have 2C plus H2 will give us C2H2, and I told you this is Hess law. Alright, and Hess law states that the individual reactions, alright, the individual reactions have enthalpy. That just is the summary. Individual reactions have enthalpy, and to get the general reaction, we must sum up the enthalpies of the individual reactions. Are we together? Yes. Alright, so now we have the individual reactions and we have the general reaction. Now the next thing we have to do, or more like the first step that we must take, is to rearrange each of these reactions so we can get this general reaction. Now when you are rearranging, look at this, guys. If you rearrange and you swap what is on the reactant side to the product side and vice versa, you change the sign. That is the idea. Alright? But then let's just look at it practically so we can understand it better. So now let us rearrange. We'll rearrange under here. Okay? So now let us look at the first reaction. Now, like I said, if you don't look at it critically, you do not understand, and I don't want you to cram. I want you to understand the steps. Alright? Now pay attention. Now the first individual reaction we have here is C2H2 plus 5/2O2 to give us 2CO2 plus H2O. And we have delta H to be minus 1299.6 kilojoules. Now I want you to do this. Look for the substance or look for the entity in this first reaction that is not in the second or the third. Look for the one that is not in the second or the third among all those entities there. Okay? Look for the one that is not in the word reaction. How about O2? It is here, right? CO2 cup. How about H2O? It's there. So it is C2H2 that is not what? In the second or the third. Look at that one that is not in any of the two reactions. Then check in the general reaction where it is located. Now in the individual reaction, C2H2 is on which side? On the general reaction, where is it? So what we have to do is that we have to now swap it so we can ensure that we place it at the exact position where it is in general reaction. That's the idea. Okay? If we have what? 2 here, for instance, we have to also multiply this guy. The aim is that that particular entity that we have chosen must be the same way it is on the general reaction. The same place, the same number of moves. Alright? So now look at this. So now let us swap. So we'll swap. So that 2CO2 and H2 will bring it here, while we send the other one over there. So this will be 2CO2 plus what? H2O to give us what? C2H2 plus what? 5H2O. Now delta H will change from negative to what? Positive. So we have 1299.6 what? Kilojoules. Whereas before we had minus 1299. The reason why we changed the sign is because we swapped. If we had multiplied C2H2 by 2, we'll also multiply the delta H by 2. If we multiply, we'll multiply by delta H. If we divide, we'll also divide by delta H. Are we together? So like I said, please don't forget. Ensure you look for the compound or the entity, the molecule, the element that is in equation 1 that you will not see in any of the other 2 equations. That is the idea. 5H2, right? Okay, that was okay. Here was 5/2 now, is it not? Gracias. 5/2O2. Alright? So 5/2O2. Okay, if you're watching on YouTube, please. That's also a correction that we just made, okay? Is that okay? Alright. So it's 5/2O2, alright? Okay, 5/2O2 from here. So when we swap, we have to bring these guys to the product side, brought those guys to the reactant side. Alright? To ensure that our C2H2 is on the same side as it is on the general reaction. Are we together? Yes. Now let us look at the second reaction. Now, in the second reaction, what do we have in the second reaction that is not in equation 1 or equation 2? C, right? Yes. Thank you. So now let us check the general reaction. Where is C located? Are they on the same side? Yes. But there is a difference, right? Yes. C has 2 here, but C has just 1 here, right?
Yes.
So now the idea is this. We will now have to multiply everything by 2. Are we together? Multiply everything by what?
2.
Including our delta H. So now look at this guy. So it means that rearranging it now, we have 2C. We don't need to swap now, is it not? Because in general reaction, we have it on the reactant side as well as here. So 2C plus what? 2O2 to give us what? 2CO2. Alright, then R, okay, our delta H will be equal to 2 times minus 393.5, punch it. Minus what? Have you confirmed that everyone? So minus 786. Any decimal? Any decimal? So minus 786 what? 786 point what? 786 point. This thing is online. People are watching all over the world. So minus 787 what? Kilojoules, right? Good. Alright, so now let's look at the third one. Now in the third one, what do we have on the third reaction that is not on the first or second? H2, right? Yes. H2. So now let us check the general reaction. Are they on the same side?
Yes.
They are on the same side, right?
Yes.
Okay. Now, so what do we do? We have to leave it that way, right?
Yes.
Okay. Now look at this. So we have H2 plus 1 over 2 what? O2 to give us what? H2O. Now delta H will be equal to minus 285.9 kilojoules. Alright? Are we together? Okay. Now at this point, what we have to do is to cancel out species. Alright? We have to cancel out species at this point. Now when I say cancel out species, I'm also talking about adding species. Alright? You add the things that are actually on the same side and you subtract the things that are on opposite sides. Similar entities. Now look at this, guys. Now the aim is to ensure that we get back the general reaction. So we can add our delta H and we'll get our answer, and that will be all. Alright? So now let us do it together. Now, we have 2 CO2, alright, here. Do we have CO2 on the other side? Do we have 2 CO2 on the other side?
Yes.
So we'll cancel, alright? So this will cancel what? This. We can only cancel on opposite sides. We cannot cancel on the same side. Alright, that cancel I'm talking about is subtracting. Like 2 CO2 minus 2 CO2 is 0. It's not as if you're dividing, you're just your subtracting. Now let us check again what we can cancel. Is there any other thing we can cancel? Yes. H2O is here, right? Yes. So H2O will cancel what? H2O. Is it not? Alright, now let's check again. Alright, now we have 2C here, right? Yes. Do we have 2C on any other side? No. We have H2. Do we have H2 on any other side?
No.
But now we have O2 here and O2 here, right?
Yes.
So we can add them, is it not?
Yes.
So we have 2O2 and 1 over 2O2. Remember, I told you, we can only add on the same side.
Yes.
So 2O2 and half O2. Now let's do it together. 2 plus 1 over 2 is it not? Yes. 2 over 1. LCM is 2, right?
Yes.
2 into 1 is what? 2 times 2 plus 2 into 2. 1 times 1. So we have 5 over 2 what? O2. So it means that adding these 2 will give us 5 over 2 what? O2. Do we have O2 on the other side?
Yes.
So 5 over 2 O2 can cancel this guy, right?
Yes.
Is there any other thing left to cancel? Now, the fact that there's nothing left to cancel, now we'll write what we have remaining. Alright? Alright. Carry the camera, come. Alright. So 2C plus. Stop that. Don't distract my online class. Please, guys, don't mind them. Now look at this. So 2C plus what? H2, right? Now please, we'll write the things that are on the same side. Now we are writing 2C and H2 together because both of them are on the reactant side, right? So 2C plus H2. Remember, when we added these 2, that we got this guy, right? So we are not supposed to include this again because we have already cancelled this by this. So 2C plus H2. What do we have on the product side? C2 what? H2. Alright? So now our delta H will be equal to Now we'll now have to add these guys. We'll say delta H should be equals to 1299.6 plus minus 787 plus minus 285.9. This is you saying 1299.6 plus minus is minus, 787 plus minus is minus, 285.9. When you do this, what will you get? 2 what? 226.7. Any other value after that? 226.7 was kilojoules. Alright, so that's it. That's it. Okay, please go subscribe to my channel.